Hi, and welcome to the second lab, or actually third lab, in AI-102, and the second lab in Vision, part of that course. This lab is titled Read Text and Images, and we're going to use OCR from AI services to do that. So again, we've already pre-created the AI multi-services account in Azure as is required, and we've also already cloned the repo here, so we have everything that we need to start. If you're wondering how that works, then please take a look at the first video of this series, where we're going to show you how to exactly do that part. So we're here in Visual Studio Code, and the code that we're looking at is here in the directory 05 OCR. And we're first going to work with the C# version, and then later on with Python again. So I first need to install the image analysis SDK for .NET. So I'm going to open up a folder here, and then I'm going to say .NET add package, and Azure.ai.vision.image analysis, and we're going to use version 1.0.0 beta 3 here. This is just because that's what the instructions say, and I don't want to debug any of the code used in this lab. So that's basically the reason. I needed to go to read text first, and then yep. So yeah, if you're really using the Vision SDKs, then of course use the kind of latest version. But like I said, for lab compatibility reasons, I'm going to use this ancient one. All right, so in our read text folder, we've got a app settings.json as normal. And we're going to quickly fill that in from our Azure resource. We should have everything done here. Yes, we do. So copying over key. And then the endpoint. There we go. And then we can take a look at our program here. So we need to start off by importing the image analysis package. So it's going to be Azure.ai. Oh, good. Vision image analysis. And then we need to create the client, same as in the last lab. Here we got all of the configuration, and then here we create the client. And then as parameters, we'll put in a new URI, the service point, and then a new Azure key credentials. we use the service key. All right, cool. So that way we can connect. And then once we have connected, make this a bit smaller here. Then what we're doing here is working, asking for the user to choose to either use the read API for an image or read a handwriting note. So either one or two. Okay, we can do that. And then here is the actual logic. So we're getting in the file name and then the reference to the client. And then here we're opening that file. And then we need to do something with it, right? So as previously, we get back this image analysis result object from the SDK. And let's just call analyze on the client object and give it as a parameter the actual file. So it was from stream, and then it was called stream, right? Yep. So we got that one, and then we also want to add features. And the one that we want for this is read, right? So that's the OCR part. Okay, then we can close our stream. And then display some results. So let's first check if we got anything back. So if our result is not null, then let's tell our user we're happy. And then let's get some drawing done. We need an image. Then let's get rid of this stuff. So system drawing image from file. And that's our image file. What was it called? Image file. Okay. Then we get the graphics resource. From the image that we just created. Okay, then we need a pen. And then for each let's call it a line. In result dot read dot blocks dot select many and we want to have here as a block lines. Yeah, that should work. So let's keep this empty for now, and then save the image. So let's say a string output file equals text .jpg, and then save. Perfect. All right. What else do we need to do? Well, maybe tell our user that we are done. Results saved. Output file. UI. Okay. So that's basically how reading works. However, of course, it doesn't really do anything yet. We're just reading it from the API. So let's fix that over here. So let's write the text that we are reading onto the for the user, right? So make some 1, 2, 3 spaces. Oops. 1, 2, 3 spaces, and then the actual. No. All right. So then we want to have line.text in here, and then we close that single quote, and then we close our double quotes. Then we should be done. And then we have our picture. So let's draw a bounding box. So I'm going to use a Boolean here to kind of remind us that that's what we're trying to do, because we need to turn that off later on. So let's put here then, if draw line polygon. And how we're going to do this, we're going to get the bounding box, or bounding polygon, I should say, of course. There we go. And now we have then a array of points. Let's call it polygon points. And I'm going to say we're going to add a couple of points. No, not name of. New point. And the first coordinate is going to be R0. Dot X, right? And then R0 dot Y. Okay, so we got that one. And then we have 3 more. So I'm just going to copy paste this. 3. And then there's always going to be the next one, right? So 1, 2, 3, and 1, 2, 3. So now we have 4 points from the bounding polygon. That's cool. So I need to remember to close this. And then we'll just draw that, right? So on graphics, draw polygon. And then we have our pen. And then we have our point array. All right, cool. So let's see if this works. Let's get rid of the code a bit. And then run the code. And we're going to use the option 1 now first for our test here. And if you remember, option 1 was talking about a Lincoln JPEG. What? 102. Oh. Yeah. Yeah, that's better. So it's just talking about the Lincoln here first, right? So if in case 1 image is Lincoln.jpg, so that's use the read API for an image. Let's go and take a look at what that image is. It's a picture of Abe Lincoln, and then there is some text here. This is probably a well-known statue in Washington, D.C., right? So we're entering number 1, and that means that it's going to upload the picture to Azure AI services, and then it gives us back the text here. So you can see, in this temple, as in the hearts of the people for whom he saved the Union, the memory of Abraham Lincoln is enshrined forever. So it got that right. So it read the text correctly. And then it also created this text.jpg file where it's then actually highlighting the polygons in which the text is in, right? Remember, then that's what we wanted to do here. There you go. This is where the text is actually located. Okay, not too bad, right? We're happy. The polygon endpoints are, of course, all available for us here, right? So we could also write that out. Maybe here. So instead of just creating the box, let's also say bounding polygon, not F1, polygon. And then put in using string.join. Oops. Space, right? And then what we want to have is the line dot bounding polygon. Okay. I don't know what that dot is doing there. All right. Let's see if this will work. I'm still missing the closing here. Yeah. There we go. All right. So now we're also writing out that information. Let's see if we can get our terminal back. And then put in 1 again. Yeah, you can see now for each line, besides just giving us the text, it also gives us the bounding polygon of that text. All right, so next up, let's do the second use case. So this is using this note.jpg file, so a handwritten shopping list, it seems. So let's see how our code can work with a handwritten image instead of, so can it also figure this stuff out? So for that, we had the other use case here. So now we enter number 2, and let's see how well it does. Okay, that's good. Shopping list, non-fat milk, bread, and eggs, and we got the bounding polygon again. So now if we take a look at the text.jpg here, you can see that it has nicely bounded the text as well. It's missing a bit of the G here on top, but otherwise fairly nice. So that's everything this time, working with C#. And next up, we're going to do the same thing again using Python. All right, so here we go with the Python version. Again, sorry, this is a different environment. I had to, due to time constraints, I had to kind of redo things for the Python option, but you shouldn't really see a lot of difference here. But yeah, so what we want to do is we want to go into the read text directory here, and then open that in the terminal, and then install the Azure SDK for image analysis. And again, like last time, I'm actually going to install the latest version. The reason for this is that the instructions tell you to install a specific beta version. However, I've had trouble using that. So I'm just going to go with the latest image analysis. I can't seem to be able to type analysis. Right. Okay, so while that's installing, we have our .env environment here. So we need to set up that with our endpoint and key. And meanwhile, we have deployed our resource. Oops, not the resource group, not the resource. So annoying. And then let's take the key. The end. There we go. So that's done. And meanwhile, okay, you do that. Meanwhile, the SDK has been installed as well. So let's go and take a look at the Python code here. So first of all, what we need to do is import some libraries. So from Azure.ai.vision image analysis. All we're going to do is import image analysis client. Then from the same place, just copy paste this, right? There's a sub package called models. Yeah, that one. And from there, we want to import the visual features. Remember, that was the way, I think it's an enum, an enumerated variable that allows us to define which parts of the image analysis we actually want to use. And then we need the key credentials as well, and that's in azure.core.credentials, I think. Import Azure key credential. Should work. If I could only spell from correctly. Okay, those are our imports that are required. Then here we the normal way we use the .env library to get the endpoint and key variables, and then we need to create a client here, and this was CV_client. CV I think stands for like computer vision originally, and we have an image analysis client constructor available that takes as parameters the endpoint, yeah, endpoint, and that's in the AI endpoint variable, and then that explains credential, and that requires a Azure key credential. So we're going to create a new one because we have a constructor for that as well that takes in a string, which is this one. Perfect. So now we've got our client. Cool. So then we have this prompt that is asking for a number. So either put in 1 for reading from an image, which is going to be a statue, the statue of Abe Lincoln that has some text on top of it. Or then number 2, in which case we're going to try to read from a handwritten shopping note. So both of these are going to call the getTextRead function. So let's go and implement that. Here it is, getTextRead, and what we get as a parameter here is just the image file. Okay, so let's kind of first, here we already have code in place that does open that file, but let's first call the client. So we're going to assign, we have a result, and we're going to call the CV client, and in it specifically the analyze function, and that takes as parameters for our purposes here image data, right? So we're just going to say image data, and that's going to be our image data, right? That's what we're reading up there, a couple of lines above. And the second thing that we need to define is the visual features, and that's a list. So let's say visual features equals the list, and we only have one thing in there, which is the visual features dot read. Read stands for like OCR. Optical character recognition. So we want to read text that is in an image. And then we're done, right? So that's kind of the request part. So then things run and we get the result back into the result variable here. So one thing that we could do is, check that the read portion of the result, which is the only one there's supposed to be, that if it is not none, then we got a proper result. So what we could do then is print like maybe text. And what we want to do is, besides just printing the text that we can read, we also want to possibly show the bounding boxes of the text on the original image. So let's do some imaging stuff here. So we want to open that image that we are talking about here as an image as well, not only as a byte stream. Image file, here we go. And we want to get a figure from matplotlib. Figure, and that takes as a parameter the size of the figure, right? And that's going to be, from the image we can get the width, and we need to remember to divide that by 100. And then from the image we can also get the height, which we need to remember to divide by 100. Okay, then we have our figure, and then we set off any axis labels, and then we create a draw or an image draw. And then we also need a color. Okay. And then kind of for each line that we have in the result, that's the result.read. And in read we have blocks. So we know that we only have one block returned to us. So we're just going to take the first block and all of the lines in it. And then we do something, right? Blah. Okay. And then when we're done with that, then, oh, where am I? How come I'm misaligned here? I don't understand this. All of this is misaligned for some reason. Okay, so then after we're done with doing blah for each line, we then want to save the image. So we do that by doing a image show. Like this is matplotlib, right? It does things in a certain way. And then we want to do a tight layout. Say padding equal 0, 0. We define the output file to be what is it? Text.jpg. And then we do fig.save. And it's going to be the output file. And then maybe say print new line results save in, and then output file. Okay, cool. This should work. Why are you complaining about my IM show here? Yeah, no, that's already there. That's that for loop. Okay. So not really complaining anything. That's good. Okay. So then go kind of into the for loop here. So for each line, all we want to do is, oops, print. Still in C# mode again. I want to print. Still formatting here. I'm going to do like maybe 2 empty spaces and then line.text in here. And then we want to take the bounding polygon. That's for the line, right? Bounding polygon. And then we're going to create our own, because the graphics needs it in a bit of a different format. We're going to create a bounding polygon that's going to contain from R, the first R, the X, and then the Y. And now this is a tuple. Oh, and I want to have a comma as well, right? And I want to have one of for each of the corners here. So 1, 2, 3, 4. And then, you know, the next one's just going to be 1 and 1. And then this one's going to be 2 and 2. Oops. And this one's going to be 3 and 3. So this way we have the 4 corners of the text box. And then we're going to draw that. So draw dot polygon. That requires a polygon that we gave it. And we want to have a color, which is 3. All right. So let's see if this works. Okay. So let's run this Python. What is it? Read test.py. Okay, everything seems to be working. Now note it's talking about, you know, one use read API for image, link on the JPEG. That image is here under images, link on .jpg, right? So you can see it's a photo of the statue of Abraham Lincoln, and then there's some text here above it, all right? So let's try that one. So number 1. And it came back with text, right? In this temple, as in the hearts of the people for whom he saved the Union, the memory of Abraham Lincoln is enshrined forever. Which probably is what it says over here, even though I can't really see that. It's too small for my eye. And then it saved some results in text.jpg. And you can see that it actually created a bounding box across all of the lines of text, right? Which is nice. Okay. Cool. So, like as an additional thing here, instead of just returning back the text, we could also actually print the coordinates of the bounding polygon, right? So maybe somewhere here, we could just say print, couple of spaces, bounding polygon, and then stuff. And we want to format that string. Up. Seems I lost my keyboard again. So this string ends and then dot format. Good. And we just give it the bounding polygon, and then it'll figure out how to write that. Okay, let's try that. Oh, let's save that, right? And then let's try that. There we go. So now you can see the coordinates of the bounding polygon as well in here. All right. Another thing we could do here is draw polygons across words, right? So the way to do that would be to kind of stop drawing here. Well, let's see how we're going to do this. And not do that part. Oh yeah, we need to do that part to get that one. Yeah. But then at some point, maybe here. Right, so let's go like for word in the words of this line. Yeah. R is actually going to be a different polygon, which is the word dot bounding polygon. And then we can reuse this part. Right, this is the same. We're just going to get the coordinates, and then instead of drawing stuff here, we draw it here, right? So it's going to be something like draw dot. Yeah, it's going to be exactly that. I'm just going to copy paste it from here. So now instead of doing the line polygons, we're going to do the individual word polygons. Okay. Let's take a look at what that looks like. So now the textual output should be, I guess, the same, right? But the picture text.jpg should be different. And it is. So instead of having the rows, we now have the individual words outlined here. Right, this is not that accurate. Huh? Okay. So we did that. And now kind of the only thing that remains is, okay, this text in this picture, this is pretty straightforward. What about some handwritten text? Like what if we have this handwritten shopping list and we want to do OCR on that? Can we do it? Well, let's see, right? If we run the same program and then enter 2 here for reading handwriting, then it'll upload this note.jpg picture and try to run the analytics on it. So I got a shopping list, non-fat milk, bread and eggs. That's good. And if we take a look at the text.jpg, you can see that how it has actually found those individual words here as well. So this seems to be working as well. All right, but that's it for this lab. I hope you enjoyed it. Thanks a lot for watching, and I'm going to see you again in the next one. Till then, bye-bye.